In this tutorial, we are going to discuss how you can list the elements when you have been given sets in a set builder notation. All right, so it's very simple. All you just need is to understand what you have been given and also to know what is the set of numbers that have been given in that given set builder notation. All right, so if you have not yet subscribed to the channel, make sure that you click on the subscription button below the video and the notification button so that you don't miss out the videos that I'm going to be posting. And in case you have any questions or you want to join my online session which I have with students, feel free to contact me using these same lines on the screen. All right, so let's quickly solve the question. All right, so the question says list the elements of each of the following sets, and the first one that we've been given is that x is such that x is a natural number less than 5. So the first thing that you need to understand in this question is what are natural numbers. So natural numbers are simply counting numbers starting from 1. So if we say natural numbers less than 5, we are simply talking about numbers starting from 1 up to 4. So natural numbers are simply counting numbers starting from 1. So when we say counting numbers, we know that when we are counting, we usually start with 0. So these are all numbers starting from 1. So we start from 0, 1, 2, 3, 4, going up. So this is how we count. But natural numbers exclude 0. Once you just add 0, they change from natural numbers to being whole numbers. So for natural numbers, we start with 1. All right, so if we say natural numbers less than 5, so I will name that as set A. So I'm going to say A is therefore going to be equal to 1, 2, 3, 4, 5. Yeah, so natural numbers, or rather natural numbers less than 5, we just have to end on 4. We're not supposed to include 5. If they said less or equal to 5, that's when we have to include 5. All right, let's quickly move on to the next set there, which says x is an integer greater than -3. So we've been told that x is an integer which is greater than -3. So integers are simply just whole numbers, including, positive and negative whole numbers. That's the simplest definition of integers. Positive and negative whole numbers, if you add them together, including 0, they form a set known as the set of integers. So we know that integers will come from negative infinity. Okay, let me not use this symbol. I'll start using this symbol and start looking at interval notations. So integers are simply numbers starting from negative infinity, and they are denoted by z in most cases, in most books. So integers simply numbers coming from negative infinity to positive infinity. So let me just write a few negative numbers there. -4, -3, -2, -1, 0, 1, 2, 3. So they keep on going like that, and then you close. Yeah, so they are saying negative integer greater than -3. So negative integer greater than -3, we are simply just talking about these two numbers here. These are the only negative integers which are greater than -3. So our set B will therefore be equal to, our second set there will therefore be equal to -2 and -1. Let's move on to part 3 of the question. So part 3 of the question says x is such that x is a positive number less than -5, and then union 1, 2, 3. So they are telling us that x is a positive number less than -5, and union 1, 2, 3. Okay, so what okay, we're talking about positive numbers less than -5. Is it possible to find a positive number less than a negative number? So the first thing that you need to understand is the first statement of the question. So if my set C, if let's say this part 3, I give it a name as set C. So say my set C is therefore going to be, one thing that I need to understand is that there is no positive number that is less than -5. Hence, that is an empty set. So an empty set union 1, 2, 3, we are combining nothing to a set. So nothing plus a set will give us that same set. So this tells us to say set C is therefore going to be equal to 1, 2, 3. So our set C is therefore 1, 2, 3. That is our set C. Let's quickly move on to part 4 of this question. So it's also a very simple question, which I believe we can solve. But let me show you for the sake of you being sure of what you're doing. Okay, so part 4, I'll name part 4 as set D. So my set D is therefore going to be, they are saying x is a positive even number. So even numbers are simply numbers that are divisible by 2, or numbers in which 2 can go into without leaving a remainder. So a positive even number less than 10. So positive even number less than 10, we start from 0. So you start from 0. So even numbers, positive even numbers less than 10, and then x is also an integer. So the problem with 0 is that you don't know whether it's positive or negative. So okay, it depends with what your instructor wants the solution to be. So if you are taught that 0 should also be included in even numbers, which is supposed to be the case, then you also have to include it here. So you say 0, 2, 4, 6, 8, because they're saying less than 10. So the problem again with this 0, which I have found, is that we don't know whether it's positive or negative. So I don't think it's wise for us to include it here. So because the question is specifically saying even numbers, positive even numbers less than 10. Because if the question was just open to say even numbers less than 10, we would have also included 0. But in this case, we will not include it because it's specifically telling us to list positive even numbers less than 10. And then we're finding the intersection with integers. With integers, because this other set says x is such that x is an integer. So integers, we're going to say -2, -1. So it's coming from negative infinity. They have not specified the range. So we are coming from negative infinity to positive infinity. So this is what we have. All right. So now we find the intersection between these two sets. So to find our set D, we simply just get what we have here, because we know that these are also integers. So because we know that these are also present there, and we're looking for the common elements intersection. So we get the same set, this one, which is 2, 4, 6, 8. So this is the solution. Let's move on to part 5. So part 5 is saying x is such that x is equal to 4k minus 1, where k has been given to be 0, 1, 2, 3, 4, 5. Okay, so these are the values of k. So let us quickly find what these are. What x is when we replace these values of k in this given expression. So when k is 0, x is therefore going to be 4 times 0 minus 1, which is negative 1. When k is 1, x is therefore going to be 4 times 1 minus 1, which gives us what? 3. When k is 2, x is equal to, x is going to be, this will be 8 minus 1, which is 7. When k is 3, 4 times 3, that's 12 minus 1, we have 11. When k is 4, when k is 4 times 4, so here we had 3, then we have 4. So 16 minus 1, that's 15. And when k is 5, we have 20 minus 1, that's 19. Yeah, so when k is 5, the value of x becomes 19. So our set E, I'll call my set for part 5 as set E. So my set E is therefore going to be, we just get these solutions there. So we have negative 1, 3, 7, 11. I think we've forgotten something. When k is 1, this will be 4 times 1. That's 4 minus 1, 3. 4 times 2, 8 minus 1, 7. This 4 times 3, 12 minus 1, 11. I think it's okay. I thought maybe we've skipped one number there. So 11, 15, 19. So this is our set E. Let's quickly move on to the next question. So the next question says x is an integer, and then we're finding the integer, or finding the intersection between the integers and this given set. So integers are numbers from, so I'm going to name this as my set F. So integers are numbers from negative infinity, so negative infinity to positive infinity. These are whole numbers from negative infinity to positive infinity. So this is what we have. So I'm intersecting this with this given set, which is 1, root 2, and 3.14, and 7. So now if we find the intersection of these two sets, you discover that the only integers that we have in this set are 1 and 7, and these are the only numbers that are present there. So we write them together there as the solution. Alright, so let's quickly move on to part B. So we're done with part A. Part B says, given that A is negative 2, negative 1, 0, 1, 2. List the elements of the following sets. So we have x cubed is such that x is a member of A. So the first one there, I'll name it as set. I'll name it as set W. I'll say let W be equal to this same set. So W, okay, let me just use the same things the same notation that I've used. So I'll just say I. So for I, the solution will be, so negative 2 cubed, negative 2 to the power 3 will give us negative 8. Negative 1 to the power 3, we're using this formula that has been given there. negative 1 to the power 3 will give us negative 1. And then 0 to the power 3 will give us 0, 1 to the power 3 will give us 1, and 2 to the power 3 will give us 8. We move on to 2. So here the formula that has been given is this one. So x squared plus x. So negative 2 squared, say negative 2 squared plus negative 2. So negative 2 squared gives us 4 plus negative 2. So 4 minus 2 gives us 2. So the first one that we have there will be 2. Then we move on to negative 1 squared minus 1. So this will give us 1 minus 1. That is a 0. So 0 squared plus 0. So we have another part which is 0 squared plus 0. I'm just using this formula. I'm plugging in these expressions there. So 0 squared plus 0 gives us 0. So we can't write two elements 2 times in a set. We just list them once. Alright, so 0 is already there. So we leave it. Say comma. We move on to 1. So 1 squared plus 1. So that will be 1 plus 1. That will give us a 2. So there is also already a 2 there. So there is no need to write another 2. Then we put 2 there where there's x. So we say 2 squared. That will give us what? 4. 2 squared will give us 4 plus 2. So that will give us 6. So this is the solution for the second part of the question. So let's look at the third part of the question. So the third part of the question is also simple. I don't know how this equation is, but I'll take it as 2 over x plus 1. So they've told us that x is a member of A, so we get the values of A and replace them there. So if we put if we put, let me just erase this part. So if we put negative 2 where there's x, so we'll say 2 over negative 2 plus 1. So negative 2 plus 1 gives us negative 1. 2 divided by negative 1, we're getting negative 2. So the first element there is negative 2. So, oh, sorry. Okay, yeah, it's okay. And then we move on to the second element in set A. So we have 2 over negative 1 plus 1. So this one gives us, this one is undefined. So, because we'll have 2 over 0. Negative 1 plus 1 will give us 0. So 2 over 0 is undefined. So this one we can leave it. Then we move on to 0. When we put 0 there's x there, the solution will be 2 because we have 0 plus 1, that's 1. 2 over 1, that's 2. So I'll write my 2 there. And then when you put 1, you have 1 plus 1, 2. 2 over 2, it's 1. When you put 2, you have 2 over 2 plus 1, that's 2 over 3. So this is the solution set for this given expression there. Alright, let's move on to this one, the last one. So the last one is this one, and the formula is 3x squared plus 1. So 3, while there's x, we put negative 2 squared plus 1. So we have 4 times 3, 12 plus 1, 13. So the first element will be 13, comma. We put negative 1 there. So when you put negative 1, you have 1 times 3, 3 plus 1, 4, comma. We put 0 there, you have 1. You put 1 here, you put positive 1, you have 4. So 4 is already there, we don't have to write it again. Then you put 2 there, you have 2 times 2 to the power 2, that's 4 times 3, that's 12 plus 1, 13. 13 is already there, so just leave it like that. Alright, so this is the solution set for this last question there. Alright, so thank you very much for watching today's tutorial. Make sure that you subscribe, click on the subscription button, and don't forget to also press on the notification button so that you don't miss out the videos that I'll be posting. Alright, so if you have any questions or you would want me to help you in physics, math, chemistry, or biology, feel free to contact me using these lines on the screen. My name is Hamted. See you in the next tutorial video. Shalom, shalom.